So we now know how to measure the EMF, we know how to write a picture of a cell. What about using these values to predict whether or not a reaction could happen, which is again something important for a chemist to be able to do. So in an electrical chemical cell, chemical energy is converted to electrical energy, so the stored chemical energy inside the chemicals is going to get converted to a flow of electrons, and as that happens, the EMF will drop to zero as the chemicals are used up, if we allow the electrons to flow. But we can predict what reaction is going to occur in our cell by looking at the values. So the first job you've got is we've been giving you a cell, we've been doing this now a bit, so see if you can label. Remember that reduction is on the right and oxidation is on the left, most positive is on the right, most negative is on the left. Can you label the parts of this cell? So if we've labelled it, we should get something looking like that. We also know that when this flows, the electrons are going to flow from the side where oxidation occurs over to the side where they're needed for reduction. So what do we remember? We will remember the one with the more positive value gains electrons and so goes forward as a reduction. So we're going to have our Ag plus an electron is going to get to go the way it's written. Okay. The more negative one has to lose electrons, so it has to be written as an oxidation. So Zn goes to Zn2 plus 2 electrons. It's going to go backwards. Now if we want to predict the reaction that's happening in that cell, we've got to combine our half equations, just like we did in redox, to make an overall equation. In order to combine these, the electrons need to match. So I'm going to double everything in this equation to make it match. So I'm going to have 2 Ag plus Zn makes Zn2 plus and 2 silvers, and the electrons will cancel out. And that is the equation that will happen in that cell by looking at those values. What would be the electrode potential? So right hand side minus left hand side, plus 0.79 minus 0.76. This is a 1.55 volt battery. So we've used the values given in the electrochemical series to predict what reaction would happen when we connect those two together. So what we know is that zinc will react with silver ions to make zinc 2 plus ions on silver. If we tried to go the other way, tried to go backwards, it would not work. The numbers would say that it couldn't work in the other direction. Zinc 2 plus cannot be reduced by silver metal. Okay, one more thing we're going to look at with this is what happens to the two electrodes once this circuit is running and the electrons are flowing. So when a current is drawn, and actually those of you that do physics will know that to do that you would have to remove the voltmeter and connect the wires. So I'm just going to put a little note to that up here, because to make a current flow, the high resistance voltmeter has to be removed. So remove the voltmeter and connect the wires. So just connect the wires without the voltmeter, and now the electrons will flow. They won't just hit the voltmeter and stop. The mass of the zinc is going to decrease. Why? So let's go back and look at our equation. So silver ions plus zinc becomes zinc 2 plus ions and silver. Zinc is being oxidized, it's being turned into zinc 2 plus ions. Whereas the silver electrode is going to what's going to happen to it, because remember silver ions are being turned into silver metal, so the mass is going to increase, because Ag plus ions are reduced to Ag. And in an exam they could then just add an AS question about moles and masses. So let's just rewrite the equation. Remember it was zinc plus 2Ag plus goes to Zn2 plus Ag, and it's asking us, the question is, if the mass of zinc decreases by 0.65, so that's the change there, calculate the change in mass of the silver. And it helps if you've balanced your equation. There we go. So you've got a mass of zinc. So the first thing you could do is work out the moles of zinc. How could you do that? So moles is mass over MR. So 0.65 divided by 65.4. Work that out on your calculator. And then you could use the ratio of zinc to silver, which is 1 zinc makes 2 silvers. So the moles of silver equals 2 times. And so then mass is missed the moles, and the MR of silver is 107.9. If you work that out, you'll then get 2.14 grams of silver from 0.65 grams of zinc. So there's another one of these mass questions here for you to have a go at. It's a little bit trickier. Why don't you pause the video, try to think through the problem yourself, and then have a look back. So the first thing you need to realise is that in one half cell you've got iron metal and iron 3+ ions. So we're ignoring the sulfate, they're a spectator ion. So we've got Fe and Fe3+. In our second half cell we've got metal X and we've got XSO4. And I have made my first bit of chemistry sort of leap of understanding by knowing that if it's XSO4 and a sulfate ion is 2-, the X ion must be 2+. So I've got two half equations going on in this. I've got one with Fe and Fe3+, and one with X and X2+. And it then tells us that when current is allowed, the ion electrode loses mass. So Fe is being turned into Fe3+. That must be +3 electrons. And that X, electrode made of metal X gains. So at the end we must be making more X from our X2+. Okay, so we must be doing that by picking up 2 electrons. Now if I want to combine those using my redox rules, I have to make them have the same number of electrons. So 3X2+ plus 2Fe goes to 2Fe3+ plus 3X. And now it's a bit easier. So work out, remember that we were trying to find the mass of X, we had the mass of iron. So now do your moles question. So there you go, you should have got the identity of X as